today we will be presenting on polymethyl methacrylate. My members consist of Parsley, Zaki, and myself, Stephanie. And the application that we are going for is as a substitute for glass. Moving on. This is an outline of our presentation today, which will start with introduction, and then we'll start with the monomer methyl methacrylate, and then go on to the polymer, polymethyl methacrylate, and then we'll go to quality control, properties, special characteristics, and then our conclusion. Moving on. So we'll start with the introduction. The polymer that we are going for is polymethyl methacrylate, or PMMA. By radical vinyl polymerization of methyl methacrylate, we can get PMMA. Moving on. PMMA exists in different kinds of names, different trade names by different companies such as Perspex, Plexiglass, Acrylite, Lucite, Optics, Oral Glass, and Xyler. Moving on. These are the simple properties and processes that PMMA can go through. My group mate Zaki will go into more detail regarding the properties. So some properties we have are the transparent, hard and rigid plastic, resistance to ultraviolet radiation, and membrane. And PMMA can go through different types of processes such as colored, molded, pre-cut, drilled, and more. So what are the applications of PMMA? Low-cost applications where transparency and weather resistance is essential, such as skylights, outdoor illuminated signs, surveying bathtub, etc. And its low density and superior toughness allows it to be used in planes, beach shields, and shed-proof windows. Moving on. So what about as a substitute for glass, as this is our main application? Compared to glass, PMMA is tougher and is safer upon breaking. It has also higher impact strength. However, it is susceptible to scratching. However, you can have protective coating to overcome this disadvantage. It is also more transparent compared to glass. We'll move on to the monomer. So this is the formula of the monomer, and each monomer has a double bond. It links up with the middle carbon of another methyl methacrylate molecule to start a chain. This is the monomer. As you can see, we have the tangent group up there and the tangent group down here. And this is the polymer backbone where we continue to form chain. Moving on. How to produce methyl methacrylate as a monomer? It reacts with acetone with sodium cyanide to produce acetone cyanohydrate. And then acetone cyanohydrate is reacted with methyl alcohol to produce methyl methacrylate. So I will now pass on to my member to continue with polymethyl.
Thank you very much. My name is Ropashilin, and I will continue about the process to make PMMA. So this is the monomer of PMMA, it is METHACRYLATE. Next. And the process to make polymethyl methacrylate is to combine methyl methacrylate with catalyst. So the function of the catalyst is to start the reactions and enters into the polymer to keep it going, but does not become the resulting, but does not become part of the polymer. Next. Okay, so this is three types of PMMA. It is flat sheet, as you can see, molding powder, and elevated shapes. Next. So, how does the flat sheet is produced? Flat sheet is produced by suspension polymerization, in which the reaction takes place between tiny droplets of other monomers suspended in the solution of water and catalyst results in grains of polymer. And the molding powder is produced by a process known as bulk polymerizations that I will explain later on. Two methods of bulk polymerizations may be used is batch cell polymerizations and continuous bulk polymerizations. Next. So this is the continuous bulk polymerizations. First, the syrup of monomer and catalyst is introduced at one end of the set of horizontal stainless steel bags running parallel one above the other. The distance between the bags determines the thickness of the sheet. The bags hold the reacting monomer and catalyst syrup between them and move it through a series of heating and cooling zones. Next, the street heaters or hot air may The spacer sits along the outer perimeter of the surface of the glass plate and forms a sealed cavity between the plates. An open cover of each cavity is filled with a pre-measured liquid syrup. The mold is then sealed and heat may be applied to help the catalyst start the reactions. As the reaction proceeds, it may generate significant heat backside. The heat is fanned off in air ovens or by placing the molds in a water bath. When the plastic is pure, the molds are cooled and baked, and the plastic sheets are ready used as is or annealed by heating them to 284 to 302 degrees Fahrenheit for several hours to reduce any residual stress in the material like chaos or pink or other damaged disability. So the final step are any excess material or flash is trained.
Assalamualaikum and very good morning. My name is Nurizati binti Ahmad and I would like to explain what makes the polymer special for application. From physical properties, chemical properties, electrical properties, thermal properties and optical properties. So for the physical properties, it has high mechanical strength, high modulus, high ion modulus and elongation at rate. It does not shatter or rupture. It is one of the hardest thermoplastic. It is stretch resistant, low moisturizer and water absorbing capacity, due to which product may have good dimension and stability. Next, for the physical properties, this material tends to creep. It most resistant to direct sunshine exposure. The mechanical properties of PMMA vary as the temperature change. And last, suitable for product intended for long air operation. For electrical properties, the low water absorption capacity is the electric properties are very good. The resistivity depends on the ambient temperature and relative humidity. For the thermal properties, it can withstand temperature as low as negative 70 degrees Celsius. It resistant to temperature change is very good. And it is combustible material which continues burning even after the flame is removed. Next, for the optical transmit more light up to 93% of visible light than glass. It can be used for replacement in circular lenses for contact lens. Does not filter ultraviolet light. It transmits UV light down to 300 nm and allows infrared light up to 2800 micrometer to pass. So the characteristics of polymer that are used for the application are many, but this is some of the examples. First, for lens transmission, UV